Luckily, we have another tool from GitHub called GitHub Advanced Security. So this is the second tool I want to highlight today. So key components of this one are, first of all, secret scanning. So if you were a bit inattentive and mistakenly submitted to your code base some secret password or something sensitive, you will be immediately reminded on that. Thanks to AI-powered scanning of the code, GitHub Advanced Security will identify this, and then you can remove it. And of course, if your secret already leaked into some public place, don't forget to rotate this. Don't forget to change password if password is also somehow leaked. So I mean, identifying is only first step in this flow. Then next component of GitHub Advanced Security is dependency review. Maybe if you maintain sorry, I hear some sound. Could you? Okay, thank you. If you already have some repos on github.com, you know what I'm talking about. And sometimes, I'm talking personally about myself. I'm a bit annoyed by this message from Dependabot, like, hey, Maxim, this dependency you use in the project that you created many years ago contains potential flaw, and you have to update this dependency. So yeah, also, I mean, very useful, right, to keep our projects in a good and secure shape. Then it contains code scanning. So literally just scanning your code for finding potential vulnerabilities, potential security flaws. And what's really cool, these first 3 points are free for all public repositories on GitHub. So please use them, please don't ignore them. And for the rest of the session, I want to focus on next level of these measures called autofix. And just imagine, GitHub Copilot can suggest security fix for your code, right? This is number one. GitHub Advanced Security can identify potential security flaw in your code. If we combine these two together, that means that we can fully automate security procedure, right? We write the code, we push it to GitHub. GitHub Advanced Security identifies flaw, and at the same time, GitHub Copilot can go and fix it or at least suggest correct code, right? And of course, here I want to say a couple of words about code QL, and this is what's actually behind code scanning in GitHub Advanced Security. This is very interesting framework, very interesting approach that treats your code like data. So imagine that all your code is becoming database for potential exploration, but code QL, you can write your own queries if needed, if you need very specialized kind of code scanning, but you can rely on many existing queries if you just need to scan your code. And of course, since this is like 100% terminal friendly tool, you can easily integrate it into your development pipeline, into your CI/CD flow. This scanning of your code could be a very important component of all the story. And also, before I show you how this autofix works, I want to explain a bit how it was created. And again, the same idea. First, of course, we create pull request with one or multiple commits. Then GitHub Advanced Security is running its regular routine on scanning the code. If some vulnerabilities are detected, it runs separate backend fix generator powered by GitHub Copilot. I mean, this is not GitHub Copilot as we know it. It's a kind of API-based one, so something that is under the hood for us. and the fix from this fix generator comes back to GitHub, and then you as a developer can take decision. So you clearly see suggested changes of the code, and it might be even in multiple files, and then you can review this, and if you are happy, you just accept and merge this pull request. Of course, in many cases, if you are not talking about hello world kind of applications, the potential change of code to remove this security might not be in one file only, right? So it might be much more complex and much more, say, difficult to fix this rather than changing a couple of lines of the code. So this is why before ever sending something to this fix generator, GitHub Advanced Security is doing tremendous job on identifying which code is actually relevant for this security fix, because again, it might be in one file, it might be in multiple files. Then for suggesting fix for this security, it might be the case when you need some extra dependency, for example, some sanitation libraries. And because of that, GitHub Advanced Security Autofix also goes and tries to identify like file where you list all your current dependencies, for example, this package JSON, to check maybe this dependency is already there. If not, it will suggest you to add some new dependency or dependencies. So I mean, definitely it's extra layer of complexity. Next point, it needs to identify proper format for displaying to you as a pilot, as a developer, for you to better first of all, easily like understand what you need to change, and second, you can, for example, not accept fix as is, but change something if you feel that this change is needed. I mean, something interesting in terms of format is needed, and of course, all potential errors that might happen on these multiple steps, because again, back to the nature of large language models that drive all this model, they are non-deterministic, they are stochastic, and I mean, let's say all these suggestions might be like, let's say, slightly fuzzy, and they can mess up something with numbering of code lines or showing current code. I mean, some extra magic is needed to make sure that what's suggested is robust and 100% applicable to your current code base. And again, something under the hood. I mean, what I mentioned now is hidden from you as a developer. So this is internal complexity. This is what my colleagues from GitHub created for you, and now you have just a very nice, clean, and clear and simple interface to work with this tool. So final prompt that goes to this autofix contains, first of all information about this vulnerability detected thanks to CodeQL. We have all the details ready. Location of source code from one file or multiple files, and yeah, it might contain like many lines of the code, but of course there is no chance to send full project, right? Because every LLM has context window, so the tool has to be very smart in identifying needed amount of code that is good for fixing this, and of course what kind of response we want to get. Now I explained you how that works under the hood. I hope that you realize that it's quite sophisticated, quite comprehensive tool. Now let's see how that works in terms of kind of front end, in terms of what we see as developers who use this tool. And I promise you will be surprised by simplicity and flexibility and convenience of how that works. So this is my last demo. It's a bit longer than previous ones, but I will explain you along what's going on here. And also along this story, I will showcase you some extra features of GitHub Copilot, maybe not directly related to security, but still might be useful for you to know that they exist. Maybe you want to start using them. Okay, let me start this video. Same project. So just imagine we start where we stopped during last demo. So we have this vulnerable piece of code that we overlooked somehow, and we want to commit this. We want to push this code to our repository. First, yeah, what I demonstrate you now is a helper for your terminal. It might happen that I forgot how to create new branch, right? Of course, maybe in reality your tasks are a bit more complex, but you can ask terminal about commands. You can ask about how to do something, or explain you to do something. After all, we succeeded with creating a new branch. Next small thing I want to demonstrate you is auto commit message. So you've seen that I clicked this sparkles icon, and instead of writing something manually, I got really nice and clear commit message. Now I'm ready to publish this branch. Okay, I can create pull requests straight in the editor, but I better switch to the website, to github.com. It's a bit more visual here. So next step is create pull request. One more feature of GitHub Copilot, GitHub Copilot Enterprise in particular, is auto messages for your pull requests. Again, instead of writing something manually, I just click the button and get very nice, brief, concise explanation of what's going on in this pull request, and I click button create pull request. And what happens next? In a second, you will see that new scanning of code is starting, and this one is by GitHub Advanced Security. Remember that this is free for all public repositories on GitHub, and you see that, okay, CodeQL is scanning my code to identify potential threats, and we can even check details of what's going on there. So in actions tab, you'll see that GitHub is creating environment to run our code, to run all these checks, etc., etc. And it, of course, identified this vulnerability, SQL injection, and now we can take some decisions, some actions there. You see that autofix is still in beta, but it works pretty stable from my experience. And it not only identified this vulnerability, it immediately offered us fix for this one. Again, this is trivial fix, right? It's just changing one line of the code, but in real projects, it might be in multiple files. You might need to add some extra dependencies. I mean, GitHub Copilot suggests you to add this dependency, so you don't have to think about this manually. And of course, we can get super detailed explanation what's this vulnerability about, and how it will be fixed exactly. Yes, so what we need to do then is just to accept this change, this fix, and I will do this by just clicking commit fix. We can write a simple explanation, and that's it. So, thanks to the magic of autofix feature of GitHub Advanced Security, this vulnerability that we somehow overlooked during our coding stage was identified and mitigated. And it's all automatic, but still completely controllable by us. And after we pushed this commit, one more security check is happening, of course, like just to double check that this security, this vulnerability fix did not bring some other vulnerabilities, and now it's fine, it's ready for merging with main